Now let's get into the basics, i.e. the actual important part. So you've hopefully from the previous slides and so far in this video, so far in this series, in the basics series, you've come to the realization of how exactly the waves are created on the ECG graph and what do they mean. Now that you have the waves created, what do those waves actually indicate? Obviously, you know time and speed is the main thing. An ECG machine runs usually at a standard rate of 25 millimeters per box. So each large square, i.e. each of these big squares here, represents 5 millimeters and usually represents 0.2 or 0.2 seconds, which means each of these little squares within the big square represents 0.04. Now, the main things I want you to know from here is simply Ecg complex consists of 5 different parts. So we have a P wave, a Qrs complex, then a ST segment, a T, and sometimes a U wave, and then this repeats. This cycle keeps on repeating in a normal, healthy patient. Now, the main things that usually when a cardiologist or a physician usually looks at an ECG, people in physiology and stuff always describe the as PR intervals as a Qrs complex, how long it takes, the duration, the ST segment, the QT interval, etc., etc. But the main things that as a cardiologist you should always look for is the RR interval. From the RR interval, you can always detect how fast or the rate of the heartbeat or the heart rate is. Usually, RR interval signifies from an R wave to another R wave. So a simple way to calculate heart rate is simply if the number of large squares between R waves. So if there's one big square, so imagine there was one R wave here and another R wave, that means your heart rate is probably at 300, which means you are sinus tachycardic. If it's two boxes, 150, 300, 75, so 100, 300, 150, 100, 75, 60. So in this case, in our ECG, the ones represented on the screen, we have 1, 2, 3, 4, 5 big boxes. So therefore, your heart rate comes around the region of 60, which is normal. 70 to 60 is normal heart rate. That's a simple way of calculating. This is how I usually get around calculating my heart rate. Now, the other thing that I want you guys to remember is, as a cardiologist, you always look for something known as a PR interval and a Qrs complex. So PR interval was the time it takes for the atrial to depolarize and then contract. So the atrial depolarization as well as contraction. Now, usually it takes around, the normal PR interval is 120 to 200 milliseconds. And this is usually represented by 3 to 5 small squares. So you need to have this figure completely by heart in your head. A normal PR interval is usually 0.18 seconds or 3 to 5 square boxes. So if you start calculating from here, start of PR up to the R wave, which is here, which starts here, there's a big R wave and a small R wave and a huge negative S wave. So this could be either AVO or this could completely be V1 or V2, depending on which leads they are. But for our sake, the R wave here would be 1, 2, 3, 4 small squares boxes. So it's in the normal range. Now, another one that usually cardiologists or physicians should usually look for are the Qrs complex. The length of the Qrs complex is equal to or less than 120 milliseconds. This represents 3 small squares. Any longer could mean that there is some sort of ventricular block or there's some sort of delay in the conduction through the ventricles because of some sort of bundle of His block and etc., which will go in through this series. So quickly, you need to know the RR interval just to measure the rate. You need a PR interval, which is normally between 120 to 200 milliseconds, which is 0.18, and then the Qrs complex, which is 0.12.